Okay, so yeah, I have a lot to talk about today, so I will try to cut the chase. But it's very good to be here in Dublin. Okay, in OWASP. I come originally from security background for a long time, and in the last few years, I've turned more to DevOps side of the world, okay, Kubernetes, and it's really great to, the wrong side. And it's really good to be here around you guys, so I really enjoyed this whole conference. So we are going to talk about Kubernetes security, okay? And usually, every cyber talk has this feeling that everyone's getting like into the conference and into the room and like, wow, we are going to hear something great here, and at the end, you come out and say, well, the world is bad. Okay, everyone tries to attack us, and like so I will try to avoid this. Okay, this is much more of I would say FY and like talk. Okay, so I want you to know, okay, what is out there. We are going to talk a little bit about an overview, a little bit about Kubernetes security. And we'll talk more about Kubernetes security posture. Okay, we are connected. Myself, one of the co-creators of Kubescape, we are going to talk about a little bit more, is a Kubernetes security posture tool, and my company Armo is also in that space. So we are going to take this direction, and mostly we'll talk about the things we are seeing there out in the wild. So again, a little bit recap about myself. CTO, co-founder, maintainer. I used to attack a lot of systems for a very long time and got fed up by it. And I decided I want to build something and not just to break. So I've moved to the development side of the security. And ever since I've stayed there, I'm contributor in CNCF and Cloud Native Computing Foundation. This is on my GitHub, my Twitter. So if you want to join me, okay, you'll be more than welcome. So Kubernetes, what is Kubernetes? I'm really happy to see that so many people came here. Okay, I wasn't expecting to see so many faces here. So how many of you are using Kubernetes? Wow. Okay. Awesome. So there is no I don't need to talk about too much, but Kubernetes is becoming the de facto, I would say, the common standard of running workloads in the cloud. If we are trying to recap a little bit, okay, why Kubernetes came alive, and I'm going to say here something very opinionated, okay, and not something that. I think that the reason why because Google felt that he will lose to AWS and therefore try to create this porting layer above the workload API just to enable people to move to Google at a later stage. So, but in general, okay, it's really this system has really become, I think, for many the favorite system, okay, to run workloads, and I can understand why. So the problem which came with Kubernetes is actually a little bit, from a security perspective, is that although, okay, the cloud security just started to ramp up, okay, in the like 10 plus years ago, but Kubernetes just created this like white spots, okay, for the security experts, because they just started to learn a little bit about cloud, about containers. Now there's a new whole ecosystem, okay, they have to learn. And sometimes it's tough, okay, it's tough to keep up because all of us who are security practitioners, we all know that the security practitioner needs to know all the details, right? So without knowing the details, you cannot understand how to make sense of your security. So, when we are thinking of Kubernetes, there is multiple reasons, okay, why people are using Kubernetes, and we did a survey with our customers, And I think that you can see that for the most, we have asked them why they think, okay, that it is important, they are using Kubernetes. And they answered, okay, those very, very nice things like improved scalability, shorter deployment time, improved availability. I don't know if you noticed, but their security is not among them. Okay. This list, just on top of my mind. And obviously there are other like things which I think that Kubernetes did not bring them to us. Okay. Like short release cycles, but I think they are just like implemented the way, the people expected them to implement, deployments and new practices. Now, anyone who have heard of Chris Romeo, or this morning's keynote speech, okay, knows that Netflix is releasing like 10 times every minute, okay, and we are not Netflix. Having said that, okay, still it is hard, okay, it's hard to keep up, okay, with all these releases, even in a smaller company for a security practitioner. So this leads us, why do we need Kubernetes security, okay? And there is a very interesting, okay, notion here. Many people think that when we are migrating to the cloud, okay, the cloud takes care of our security. Oh, yeah. No comment. Okay. But there is a very, very important part of it. Okay. Since all our infrastructure is actually defined as a code, what is called as a configuration. Okay. We have to take very big precautions in order to make sure that this configuration is secure, okay? And we are defining secure objects because this configuration is going to be turned into our infrastructure, right? And this is why Gartner mentioned that as they looking at it, that okay, most of the cloud breaches will come from misconfigurations. Okay, they mentioned this 99% of security breaches are coming from misconfigurations. Now again, let's take it. Okay, it's Gartner. Okay, let's take it into know that what they are talking about. But if we are defining everything as misconfiguration, right, everything is going to be a misconfiguration problem. But it's still an interesting notion. Okay, and if we are going further, okay, into rabbit hole, okay, we know that we can see a Kubernetes from two security directions. Okay, one is the posture, how we have defined, okay, the Kubernetes cluster, how the workloads are defined, how we have delivered our secrets into the cluster, all the things around, okay, how we have defined our access criteria, okay, for the users and so on. And we can talk about runtime security. So obviously, okay, I think that most of this conference is talking about runtime security, and I'm not, okay? What I'm going to talk about with you more is about more of the posture and definitions and how people are using Kubernetes. And I think that one of the interesting things is, and I always heard during these 2 days, I heard this notion of discussing, okay, whether shift left, shift right, shift whatever, wherever. Okay, I still think that, and I think that there is general agreement around here that the thing which infrastructure as a code enables us, okay, is to test things ahead of time, even before deployment. And I don't think that anyone questions that it's the right thing to do. Maybe it's not enough, but it must be done even before other things. So this brings me to the project, open source project we started, I think a year and a half ago. And I have to insert here a very short and private story. Okay, NSA came out with its recommendations about how to configure a Kubernetes cluster and manage it securely. Now, we said, well, let's make a tool of it. Let's make a tool which scans your cluster and tells whether it stands in the hardening rules of NSA, and like paragraph going through it and creating an output for it. And like we went through invested in it, I think a week or week and a half with my friend David, and came out, released the tool. Okay, maybe I've sent a Twitter message about it. I don't know where we've published it, but we released it in GitHub. Now we went home. I think it was a Friday. Went to sleep, weekend, and I think on Monday my friend from the US calls me and says, "Well, you are awesome. Your tool is great." I said, "I'm happy to hear. Do you know how many stars do you have on GitHub?" I said, "I don't know, 2, 3, 4." I said, "Man, you have 500 within like literally 2-3 days." And you can see that Kubescape had this high speed of traction on GitHub, and it was a tool we released in order to enable users to scan their clusters for security misconfigurations according to NSA, and it became a really, really big hit. Now, what it enables you is it enables you to tell you what's wrong in your clusters, but in the same time, it was very important for us, even when we wrote the first line of code, okay, not just to scan the cluster through Kube API and scan the Kubernetes object and tell what is wrong in them security-wise or compliance-wise, but also to be able to scan your YAML files, your Helm charts, and your customized files. This enables you to like build this whole process of working from like the developer side to the actual application deployment side. And like you can, we have our Visual Studio Code extension. So while you're writing, the Kubernetes YAML files, you already get a feedback about them. And just, like a month and a half ago, Kubescape was accepted to CNCF and become a CNCF project. Yeah. Which is, I think it's extraordinary, in the sense that I think that I don't think there are a lot of projects which are, start CNCF journey when they already have like 7K stars. So, we are aiming, incubation this year, but we'll talk a little bit more later. So what is also important for us is giving you a general security posture. So going from the configuration scanning side, we went to scanning for application vulnerabilities inside the Kubernetes cluster, because many people said that it was very, very important for them. And we agree in general, but we'll talk about it a little bit later. And it was really important for us, not just to give you, here is all our findings, like do it yourself, break your bones, and try to solve it. But we tried to do in a way that you can get solvable issues that you can implement very fastly. We are giving you automatic remediation proposals, to all these issues we are finding, and to prioritize them properly. So we are saying, that whether an issue is really looks like a high severity issue, or it looks like something that you can live with for a while. Now, how it is connected to my company is Armo has a platform which actually, receive the data from this tool and enables you to, in its SaaS environment, enables you to overview all the clusters you are having, all your registries, repositories you're having, and see all the issues in everywhere, and gives you an overview and a time-based view over that. But why we are coming to this, Because we have huge number of users, also open source, and also the Armo platform SaaS, and you can see all these names, all these companies. You can see all these users, and I have to tell you, that beyond obviously, that there is a business venture behind, the Armo itself. For us, for open source developers, it is really, really great to get all this feedback, from everyone, and all the love, which is a big thing for us. But what's more interesting that today we have, I think, more than 400 active customer accounts, and I don't want to go into this what we call an active account. We have way more inactive accounts, but we have 400 customers who are actively using the UI every day, and more than 1,000 who are sending data to our SaaS array. So we've got a lot of data. So what do we do today with a lot of data? We're starting to play with it. That's a great thing. To play with the data. So what kind of data do we have? And this is going to be more or less the structure of the rest of the talk. we are having this layer of configuration of Kubernetes clusters, which we are going to talk about, how they are configured. We are sending Kubescape scans the cluster API, the host. Okay, it scans a little bit the cloud API and sends all its findings to the Armo platform. Or by the way, it can also, you can also use it locally without the Armo platform. But in general, okay, we have this information for our users for a given time. And we also have vulnerability information. We are scanning all the images from our users' cluster, from the repositories they've set up. So we have all these image scans in our backend. I don't know if I can. Let's say so. We have an Elasticsearch cluster, okay, storing all these scan data. So we have an easy way, okay, to query them. So just to give you a little bit feeling about the data set we are working with, which I'm going to show you. So we have close to 17,000 different clusters in our data set. We have seen more than 40 million Kubernetes objects, which are ranging from like Kubernetes deployments to RBAC objects and so on, config maps. We have seen 178 container registries. We have with like nearly 50,000 container images and image scans, and we have seen nearly 2,000 GitHub repositories, which contains Helm charts and YAML files, okay, which are meant to deliver to Kubernetes clusters. So we have this whole bunch of data, and the first step what we are going to look at is actually the configuration scans. So we're going to look at the Kubernetes objects out of the two things which I told you, and we are going to compare the interesting numbers we found, the statistics we made to the general sample, to the whole population, to what we are seeing in CNCF graduated projects. And I'm going to talk a little bit more about what is it. So we are going to look at the distribution of the controls which failed and issues which been reported, and we'll try to make sense of the control failure ratio and understand a little bit of the hard things. Okay, we are seeing. So just a little bit about the data. We tried to make sense of a little bit of the data and compare open source projects to the whole population. It is really hard, okay, for a data set to say what is an open source project and what is not. And we decided to go with the graduated project of CNCF. There is a project life cycle in CNCF, which starts by sandboxing. Okay, every entry-level project starts there, just like us. They're going to incubation. The incubation already requires you to work in a very specific way with your open source. You have to have maintainers for multiple companies. You must have a decision-making process, or the early quality requirements before going into what they call the chasm, whereas most of the projects fail, okay, because there is an early adoption, okay, around projects, but they are not really able to go through that. But those who are able to, and there are big adoption around that, are going into what they call graduation, which already requires a lot of quality requirements, among them security. So there is a whole big security process around this open source project, how they are managed, and the reason why I've chosen these graduated projects, because I wanted to a little bit see whether the graduated projects are a little bit better from a security perspective than the general sample. And I know I'm killing the punchline, but yes, they're a little bit better. So the way we are going to look at the things is a little bit way we are self-representing the information. So in the Kubescape world, there are things which we call controls. Controls, a little bit, it's like a single test of a single property of an object. Frameworks, which are frameworks which are containing different controls, and think about it as compliance frameworks. So you have like, if control is a requirement, then a framework is a group of, or a bunch of multiple requirements. Like think about SOC 2, or I don't know, something alike. And we have a lot of them. So if I return to the notion of controls, controls in Kubescape is really, again, is something, a single test, okay, we're running. So think about it. We're trying to very focus it on a single property. Usually there are multiple properties when in more complex controls, contextual information, which is important. But think about it as, in these examples, you can see that you have like controls for detecting privileged containers, whether your Kubernetes service account is mounted into the container, whether a container is open to external traffic from the public internet, whether the workload has a critical vulnerability, and so on. And we are going to talk, around these things. So the reason we wanted to create statistics around our frameworks, and as of today, we are supporting even more frameworks. But when I started to work with this data, we only supported 4. So we have the original NSA CISA framework with its own requirements, the MITRE framework by Microsoft. Microsoft created this great paper on how to secure Kubernetes clusters. We have our own suggestion framework, and there is a DevOps framework for best practices for the DevOps people. And the reason why we are not going into this, because I haven't found it really interesting, as it turned out that most of the failures around these frameworks were really correlated to each other, and I thought that it wouldn't be interesting. So therefore, there is no real reason to discuss this. But if we are looking at a specific scan, okay, we are doing, and we are scanning all of our, today we have more than 150 controls. Most of during the time where we created this sample, we had around 100. So we try to check for per every cluster we are scanning. Okay, how many of the controls are failing? Okay, out of all the controls, trying to get an initial information. And as you can see that there is an interesting distribution here, okay, because like you can see that the 14 controls have failed in most cases. What does it mean? That there are 14 very common security issues, which are most of the clusters having common. And the distribution gave us an idea, okay, to go a little bit deeper and try to find out, okay, what these controls are and what are the security issues which we see in this general population. So when we looked at the general population, we started to look at what are the most failing controls, and I'm just showing here 10 out of the 14. So if I'm going to, we'll go into it a little bit deeper. But the first control you can see on the left is what we call 17 immutable root file system. It's a control to check whether the container has an immutable file system configured. Obviously, if the container file system is mutable, the attacker has can write things on the file system very easily. So in general, it's a good idea, okay, to turn it off if not needed. Actually, I have to tell you that it's really hard to configure it properly, okay, because most containers do write, okay, inside things. So you have to go into each folder, okay, which they are using for writing, and define it as the external amount, which is a big hassle. Their resource limits are returning as a control which are failing in many places, in many directions. So I hope that most of you have dealt with Kubernetes before. Okay, you know that limiting your containers is not just a good thing from a security perspective, but it's also a really good thing from a general operational perspective. Okay, you can calculate how much CPU and memory your application is going to use and limit it. But from a security perspective, it's really clear, okay, that any kind of denial of service attack can be more effective in a place where the containers have unbound memory and CPU usage. Non-root containers, we'll go talk about a little more. Okay, container is running as root container, and it's a bad thing. Allowing privilege escalations inside the container, so SUIDs can be used. Memory, again, limits, label usage, which is not, I don't say it's not a security issue, it's more a DevOps issue, and security, applying security context and seccomp profiles. And the last one is automatic mapping of service accounts. We'll talk about it a little bit later. Just now to compare a little bit about the graduated projects. So the interesting thing was here that I expected much less issues around that, but they turn out that they are not really. There is not a big difference among the two kind of. They're a little bit better than the general population. Mostly, as you can see, that again the limits is an issue in general. An immutable file system and non-root containers and other things are a little bit pushed back, so they are less prevalent. But let's just going into a little bit deeper into the controls. So non-root containers. Anyone here who can explain me what can a root do or inside a container? And what is different to having a root inside the container and outside the container? Take over the host. It's not directly can take over the host because it's confined by the container. Okay, so it has its own C group and namespace and sees only like part of the host file system. Still, it has the user ID of 0, right? Anyone, why it is important not to have root containers? Yeah. No, you cannot. You only you need so by default the container runtime will remove you the capability to do all these good things like loading kernel modules and stuff like that. Okay, good point. Okay, we are not talking about capabilities, but let's say that this doesn't have any capabilities. So the reason why it is a very bad idea, okay, because most of the kernel exploits, okay, which are working around containers to escape a container confinement is they are working mostly with when the user ID is 0. So think about it, okay, if the kernel, despite that your processes inside the container are very confined, they are removed for all their capabilities, still inside the kernel structures, your user ID is 0, and it enables you different code paths, better code paths for the attacker than if it would be a non-root container. So in general, people would say, well, this root inside the container is not a root outside the container, and it's completely true. Having said that, still, if you want to make sure that, not sure, but if you want to make the life of the attacker very hard, you have to reconfigure your containers to run as non-root. So in the general sample, 91% of the containers are running as root, and inside the graduated sample, 84%. Let's go on. Immutable file system, I've talked to you a little bit about before. So it's a test checking, okay, whether your file system inside the container is writable. And mostly I don't see a big difference here between the two samples. Okay, the general sample is 97%. Most containers today are configured without this protection. And I know, as I told you before, I know why, because it's a little bit hard to configure it. But the graduated projects have a little bit more which are configured with this. So disable automatic mapping of service account tokens. Service account tokens, anyone know what is it in Kubernetes? Anyone? So service account is a subject in the Kubernetes authorization system, which is given to software and not users and groups. Service accounts can be used to access Kubernetes API. And as of Kubernetes today designed, every Kubernetes container gets this default service account of its namespace. And it means that it automatically has some access to the Kube API. At least it can get authenticated. It may not be authorized to do things, but it can be authenticated. Now, I can tell you that the most containers which are running inside Kubernetes, and I don't have a specific number for it, but most containers who are not infrastructural containers, but application containers, doesn't use service account token. So there is no real need to give containers access to the Kube API. So if an attacker is able to penetrate your container and get execution over your container, it will find a token which on the file system which can use to talk to the Kube API, and it's a bad thing. So in the general sample, most of the workloads are configured to 81% are automatically mounting service account tokens, and 69 in the graduated sample. Applying security context. So a security context in Kubernetes is a configuration for containers and pods, which enables you to limit your container behavior in different ways. You can define SE Linux profiles to be associated with. You can define a seccomp profile. All of them are not easy to configure, but very, very good for security. And also you can, here's the security context are a way to change the user ID of your container and so on. And it's important, okay, to at least define it in a basic way. So as I told you before, defining it as non-root container, trying to take off privileges from container which are not required. And as I see today, there is a big difference, okay, again, between the graduated projects and general sample. 77% for the general sample was a surprise for me. I thought it would be much less, because usually people are not investing a lot of time into security context, but it's still something to start with. And as a lot of these numbers, I think the interesting thing is that I try to calculate here what's the percent of controls failing in each sample and each workload. So in each Kubernetes workload, try to see what's the percent of the controls is failing in general in this sample in every workload. And there is a slight difference, okay, between the two samples. I wouldn't call it very something that we can learn a lot about from it, but I can see that there is slightly better, okay, in the open source graduated projects. So getting back to the general numbers, because I thought it would be interesting, okay, just to look again as an overview of the Kubernetes solution space. We can see that there is in the container security, if you're looking at above, 75% of the containers which we are seeing, have at least one high or critical vulnerabilities, which is a lot. We can see a lot of people are attaching shells into their containers as their daily work, which is, I think it's not a good sign anyhow. And as I told you, a lot of containers running as root, and here is the general sample has been combined with the graduated sample. So in our sample, we've seen customer accounts where we've seen half of them are using only single cluster, or a little bit more in 2 and 3, 5 clusters. We can see a few, with customers with a lot of, with bigger number of clusters. And inside the number of nodes inside the cluster, you can see that most of the clusters we've seen in the sample have less than 5 nodes. Then there are medium clusters from 6 to, I would say, 15 nodes, which is also not so big. And 8 and up are less in the sample. We can also see that there are a lot of OS vulnerabilities around. We are also scanning the operating system behind the Kubernetes node. And we can see that there is a big prevalence, also here relatively too high to critical vulnerabilities. These are not image scans. These are VM scans. And I think that the other interesting thing is that when we've asked users, okay, where and combine it with our statistics, where they are scanning their container images, most of them only scanned them in runtime, and a lot of them in CI/CD pipelines, which for me actually it makes a lot of sense, okay, because you want to prevent vulnerable images getting into your cluster before they're actually being started to use. And there are a few who are scanning their whole registries already. So just a little bit, again, some numbers. Kubernetes is built on container runtimes. Most of the, Kubernetes clusters today still use Docker as their Docker container runtime, but we see a lot of containerd as well, and a few CRI-O implementations. There are a lot of alerts. Okay, we've started to detect around Kubernetes clusters. They are not really, I would say, security related alerts. So therefore, I won't go inside. If you want to see it a little bit more, okay, I will post in Sketch the whole all the slides. So you'll be able to, if you're interested, you will be able to go into a little bit more. So now we're going to the container image scans. Now I know that we are in an AppSec conference, and some of the things will be really, clear for you, but a lot of Kubernetes practitioners were really surprised by a few things, and I tried to adapt to them, explain them, okay, what is their relation to these vulnerabilities which we are seeing in their clusters. So we are going to compare a few properties of the two samples we've been working with. We're going to look how the distribution of severities of these issues are coming up. And I think the main thing is going to be reviewing the top CVs in both population, and go talk a little bit about their relevancy. So images, image repositories, okay, with the most scans in the general sample. You can see a lot of Argo CD, Redis, again, Argo, Prometheus, MongoDB, Datadog agents. Already within this table, you can already see a lot of open source graduated projects. If we're going to the graduated sample, you can again see Argo CD, Prometheus, and Kubernetes components themselves. Okay, we've seen a lot of these images. Now, if I'm comparing, okay, the distribution of the vulnerabilities of the issues we are finding, we can see a little difference, okay? Because if I'm looking at the distribution again of the severity, I can see that there are going from critical to high. There are a little bit more critical issues in the graduated sample, but much more high severity issues in the general sample, and a lot of issues around which are negligible also in the general sample, and a lot of medium issues in the graduated sample. So I've tried to make a little bit sense of it. Couldn't really, put my hands on what can be interesting. So I started to look at what are the top vulnerabilities in the general population. I'm sorry for this that this table is cut, but by far in the general population, I saw the first CV you see in the first line, 22, 28, 391 was one of the most prevalent, okay, by far, in all of our scans in the general sample. We have seen 36,000 image scans, okay, with this issue. Thereafter, it's a busy box issue. We'll talk more about it. There is after it, the numbers are really getting back to close to each other. Okay, you have few several issues which are on 100 and so on, and after it goes a little bit down. Now I just looked on high and critical severity issues for the sake of this discussion. I thought it would be interesting to talk about issues which are like medium and below, and there is good reason for it, and we'll talk a little bit later. So the first issue, okay, which was by far the most common, is a BusyBox issue. Now, why do we have BusyBox inside the container? I would love to hear if someone. It is small, but why do you? You're right. You need these tools, but why do you need these tools? I'm writing, I don't know, a Java application. Why do I need BusyBox in the container? Yeah. Maybe for debugging. Do we like debuggers, by the way, in security cons? No, not really. So the reason why you have BusyBox inside, because right, BusyBox is I would say the Swiss Army knife, right, of the shell. It's small and it contains a lot of tools we are using, and as you can see in this case, it also contains netstat compiled inside. But in order to answer, okay, my own question, the reason why it is there, because the way we are building containers, okay, opening directories, doing all this stuff is the way that we have to add these tools inside the container. So the way Docker defined first, like 10 plus years ago, the way we are building containers layer after layer, okay, in order to execute a command inside the container to build the next layer, you need to have these tools inside. So if you want to do an mkdir command inside the building process in your container, you must have a mkdir executable, which is BusyBox gives you it. So BusyBox is coming with a built-in netstat, where if you are parsing your DNS record with netstat, you're prone to a takeover by a malicious record. So I don't know if any one of you have used netstat to parse DNS records. I even don't know that it is possible, but it is possible. But it not just can take over your terminal, it can also change the colors of your terminal. So it's I think I can't resist. I love this the CV definition here, because yeah. Colors are important. Now, so I've tried to think, okay, how relevant, okay, in cloud native environment, if you're running inside the Kubernetes, can this be exploited? And honestly, the answer is no. I don't really think that this is like 2 minutes. And that, I thought I have an hour. Oh, okay, 15 minutes. Okay, so I'm going to be very fast from now on. Bear with me. So it's not relevant. Let's go on. Okay, libpcrypt. Again, an issue, okay, of side channel attack on libpcrypt. Okay, vulnerability which was there. Why is it inside the container? It is inside the container to validate in packages. Okay, we are downloading with your package manager. Now, again, in order to validate packages, we know that we are using public keys, so there are only public keys inside the container. A side channel attack on a public key is not really interesting, right, guys? So this is not an interesting attack again. SQLite heap-based attack, which is actually, I have to tell you that it is actually a very nice attack. I read a lot about this, but again, you have to have as an attacker, you have to be able to inject an SQL query to be able to take over. So even before you've taken over the container, you already have SQL injection. So just saying. So as it turns out, as I've went through all of these, I've seen, okay, that there are only two which I can say that are close of the top 10, which I could say in some very rare cases that can be exploited. So I must say, well, honestly, this image scanning thing is not really good. So when I went to graduated projects, and again, because I thought that we have more time, but I will go through it very fast. Okay. the first issue, okay, it turned out that, which was the most prevalent, it turns out that it is a bug in the scanner itself. It misidentifies a package and a Go package to a C package, and it put this vulnerability actually on the C package and not in Go, so it's not a real issue. And it turns out, okay, that out of the graduated sample, okay, there were 5 which I would say exploitable issues. If I'm looking, okay, at this the distribution of issues, you can see a huge difference, okay, between the graduated sample and the general sample. Graduated projects has way less vulnerabilities in them than general in the general sample, any kind of other project. And I started to say, well, okay, CNCF is awesome. Okay, we are very, very happy. Okay, and but then, the engineer inside me kicked in and said, well, let's start to ask questions. Okay, because it is clear for all of us, okay, that image vulnerabilities found by the scanner is not the same that something that you can exploit. Okay, actually, it's very far from it. And we have in Kubescape, we have a tool which called Sniffer. Okay, which uses eBPF. It's a POC project. It's not for production, but for our own research. But we are building a great feature of it, that we are actually looking at the workload behavior during the runtime of the container, seeing which software packages are opened inside the container using eBPF, and feeding it back to the scanner. So we are discarding all the packages from the vulnerability scan which are not running inside the container. And it is great, okay, because as it turned out, and I'm coming back here. Okay, so you have this Nginx coming out with 400 vulnerabilities, and only 4 of them are actually running inside the container. So it's really fun, okay, to see that how bad the image scanners are. I mean, not that bad. They are doing what they're doing, but they are not really useful for our security people. So I've tested again, okay, a lot of the images which been in our general sample, and used only the relevant vulnerabilities, and this is the corrected results. So you still see a big difference, okay, in the number of vulnerabilities between the general sample and the graduated project, but you can see the difference is not 1 to 10, right? So it's it's something that is making a little bit more sense to us. So we can see that actually it's much better. The question arises, okay, that's why I don't know if you noticed, okay, but the numbers of the graduated sample haven't nearly changed here. So now the reason for that is that most of the CNCF projects are written in Go, right? And Go as a single binary loaded into memory. So we didn't really have a way to define which are unused code paths and so on. So it's less interesting. So closing thoughts. In the vulnerabilities, there was I think that there is obviously we could show that there are less vulnerabilities around CNCF graduated projects, but I can't say for sure that they are better from a security perspective for 100% because I haven't checked, okay, which can be actually exploited in which scenario. So, but there is a good hunch that they are better. And in the misconfigurations, okay, we've seen that that the general population and the open source population are really close. There is slight, they're slightly better maybe, in the graduated projects, but there are no real, difference. And I think that there is a lot to do around, okay, securing the configurations about Kubernetes clusters, because both of them are, in my point of view, most of them are really bad, okay, and they really have to improve. So, questions? Yeah.
Yeah. So you're looking at vulnerabilities and configuration.
Right.
On the configuration side, if Kubernetes clusters are running as a managed service on AWS or Azure or GCP, would you find that there's certain configurations which are just sort of inherent in the way the cloud providers
So very good question, and good that you asked it, because I should have explained that we have tests which are like in this sample which we used. I've eliminated all the controls which are going from Kube API and below. So all the things which are related to the Kubernetes infrastructure, okay, which are very, very different in the case of who is managing the cluster, whether you are doing it on your premises or whether AWS or EKS. I didn't want to put in because I felt that they are not really meaningful. I need to work a way around, okay, how to make them interesting. But I have to tell you that in the case of the controls we've seen, they are the very same from each. These are like from the cluster API and north of it. Okay, everything like things we are checking, like whether your Kube API server has been set up securely. Okay, we have controls around that. I cannot test it for AWS, and honestly, I think they are doing a good job. So there's no real point, okay, of like comparing, AWS to like on-prem.
Another question?
Yeah. I can show you. In the UI, it's much more easy. In the Visual Studio Code, it is like half easy. But in UI, you can see it very clearly. Okay, that this is the line you have to change.
Another one?
Yeah. Thank you very much, guys. Cheers.